Let's look at how we can discover the transformations on a logarithmic function. Let's first talk about this a value. If you notice that this a value is not being directly multiplied with the x. In fact, we're taking the log function first, and then we're multiplying it by a. So this has to be something that's going to change the y values since x is not being directly affected. So this a, however we describe it, is a vertical change since it's affecting the y values. So let's look at what happens. As this a value changes, what's happening vertically? Well, it looks like the graph is getting pulled up further and further. And as the a value gets smaller, it looks like the graph is being pushed down more and more. So our a is going to produce either a vertical stretch, in other words, we're pulling the graph up, or a horizontal compression. In other words, we're pushing the graph down. Our b value, the value that's being multiplied by x before we do the log, we have to call this a horizontal change. It's horizontal because it's affecting the x directly. We're multiplying by x first, and then we're going to take the log function. So let's notice what's happening in the horizontal direction. So it looks like as b gets larger, we're pushing the graph in from the right. And as b gets smaller, looks like we're pulling it towards the right. So this is going to end up being either a horizontal stretch, in other words, we're pulling it horizontally, or a horizontal compression, in other words, we're pushing it horizontally. The h value looks like it's moving it left or right. And if you notice, h is directly affecting our x value, so we have to call it a horizontal change. So it's a horizontal translation of the graph, either left or right, when we're looking at the h value. The k value, which is what we put down after we've done everything else, is going to affect our y values. So it's not affecting our x directly, it's affecting our y values. So this k has to be called a vertical change. It has to be called a vertical change. So how's our graph changing vertically? It's kind of hard to see here, but if you look at it vertically, it looks like the graph is being pulled up as the value increases. But as it decreases, the graph is being pulled down. So it's going to affect basically a vertical translation of the graph. So it's a vertical translation up or a vertical translation down. So first, we notice that our a value is not directly affecting our x, so we have to use the word vertical to describe it. And from what we looked at, it was either pulling the graph up or pushing the graph down. So we're going to say that it's either a vertical stretch if we're pulling the graph up, or a vertical compression, depending on what the value of a is. So either a vertical stretch or a vertical compression. Now let's look at in this case, our d value, what it is that we're multiplying by. So this value, if you notice, is directly affecting the x. We're multiplying by this value before we even take the logarithm. So this has to be a horizontal change. And what we noticed was that this horizontal change was making the graph either be pulled to the right or pushed from the right. So this change is going to be described as either a horizontal stretch if we're pulling it, or a horizontal compression if we're pushing it. For the h value, again, this is directly affecting our x value, so we have to call that horizontal also. So this horizontal change moved our graph left or right. So this particular change was a horizontal translation of the graph either left or right. And now our k value, that one is done after we've done everything that we can, after we've done the log function and everything else. So this one is not directly affecting the x, it's affecting the y values. We have to call this a vertical change. And from what we remember, this vertical change is moving the graph either up or down. So this one was a vertical translation, and it was moving the graph again either up or down.